Welcome. We'll be looking at chemistry for starters, and discussion will be based and centered on separation techniques. And before we go to separation techniques, I want to make some simple definitions of some terms, such as solute. Solute simply means solid material, while solvent means liquid material. And a solution is made when a solute dissolves completely in a solvent that gives a solution, while a mixture is formed when a solute does not dissolve completely in a solvent. A mixture is said to be formed. Now we'll be looking at separation techniques or standard separation techniques of mixtures. I'll be looking at a few examples of each of them. The first one to discuss is filtration. Filtration involves passing a mixture through a porous material, such as a filter paper or a membrane, to separate the components based on their particle size. I repeat, filtration involves passing a mixture through a porous material, such as a filter paper or a membrane, to separate the components based on their particle size. Example is separating sand from water by passing the mixture through a filter paper. Separating sand from water by passing the mixture through a filter paper. Number 2 is decantation. Decantation involves separating a mixture of liquid and solid by carefully pouring the liquid into another container, leaving the solid behind. I repeat, decantation involves separating a mixture of liquid and solid by carefully pouring the liquid into another container, leaving the solid behind. Example is the separation of mixture of water and oil by decanting the water into another container. Example is separating a mixture of water and oil by decanting the water into another container. The next one is distillation. Distillation involves separating a mixture of liquid based on their boiling points by heating the mixture and collecting the vapor of the components with the lower boiling points. I repeat, distillation involves separating a mixture of liquids based on their boiling points by heating the mixture and collecting the vapor of the component with the lower boiling points. Example is separating a mixture of water and ethanol by distillation, collecting the ethanol vapor and condensing it back into a liquid at the other end. Example is separating a mixture of water and ethanol by distillation, collecting the ethanol vapor and condensing it back into a liquid at the other end. Next is crystallization. Crystallization involves separating a mixture of solid by dissolving the mixture in a solvent and then allowing the solution to cool down slowly, causing the component to crystallize out of the solution. Crystallization involves separating a mixture of solids by dissolving the mixture in a solvent and then allowing the solution to cool slowly, causing the components to crystallize out of the solution. Example is separating a mixture of salt and sugar by dissolving the mixture in water and then allowing the solution to cool down slowly, causing the salts to crystallize out of the solution. Again, separating a mixture of salt and sugar by dissolving the mixture in water and then allowing the solution to cool down slowly, causing the salts to crystallize out of the solution. Next is chromatography. Chromatography involves separating a mixture of components based on their interaction with a stationary phase and a mobile phase. I repeat, chromatography involves separating a mixture of components based on their interaction with a stationary phase and a mobile phase. Example is separating a mixture of ink pigments by paper chromatography using a paper strip as the stationary phase and a solvent as the mobile phase. Next is centrifugation. Centrifugation involves separating a mixture of liquid and solid based on their densities by spinning the mixture at high speed. Centrifugation involves separating a mixture of liquid and solid based on their densities by spinning the mixture at high speed. Example is separating a mixture of blood cells and pigments by centrifugation using a centrifuge to spin that mixture and separate the component based on their density. Next is magnetization. Magnetic separation involves separating a mixture of magnetic material and non-magnetic components using a magnetic field. I repeat, magnetic separation involves separating a mixture of magnetic material from non-magnetic material or components using a magnetic field. Example is separating a mixture of iron filling and sand using a magnet, attracting the iron filling and leaving the sand behind. Separating a mixture of iron filling and sand using a magnetic field, attracting the iron filling and leaving the sand behind. Flotation involves separating a mixture of solids based on their ability to adhere to air bubbles. Flotation involves separating a mixture of solids based on their ability to adhere to air bubbles. Example is separation of mixture of coal and rock particles using flotation, adding a suffocant to the mixture and blowing air through it, causing the coal particles to adhere to the air bubbles and rise to the surface. Separation of mixture of coal and rock particles using flotation. So the coal has that tendency to float, while the rock will settle at the base of the solvent. Electrophoresis. It involves separating a mixture of charged particles based on their size and charge using an electric field. Example is separation of mixture of DNA fragments using gel electrophoresis, applying an electric field to the gel and causing the DNA fragment to separate based on the size and the charge. So we have looked at few examples of separation techniques. We've discussed separation techniques starting by looking at flotation, and we said it involves separation of mixture through a porous material such as filter paper or a membrane. We talked about decantation, that involves separation of a mixture of liquid and solid by carefully pouring out the liquid into another container. We said distillation involves separating a mixture of solids based on their boiling points by heating the mixture and collecting the vapor of the component with the lower boiling point at the other end. We talked about crystallization. It involves separating a mixture of solid by dissolving the mixture in a solvent and then allowing the solution to cool down slowly, causing the components to crystallize out. Talk about chromatography, that it all involves a separation between a mixture of components based on their interaction with a stationary phase and a mobile phase. Talk about centrifugation, which involves separation of a mixture of liquid and solid based on their densities by spinning the mixture at very high temperature, high speed, very high speed. Talk about magnetic separation, that is using of magnetic field to separate magnetic material from non-magnetic material. Also look at flotation as a method of separating solids based on the ability to adhere to air bubbles. We use the example of coal and rock, where the coal will float on water, while the rock will settle at the base. Also look at the electrophoresis, which involves separating a mixture of charged particles based on their size. I have few questions for you to attempt and to please pass your opinion on the comment section. On the comment section, I will appreciate if you can do this. Number one, there are some other separating techniques that have not been mentioned here. I want you to mention some of them and explain briefly how they can be used to separate mixture. There are some other separating techniques that have not been captured in this discussion, so I want you to go through them and to mention some of them. Number two, there is this tendency for a solid material to pass to be converted directly to gas without passing through the liquid state. What do we call such material that have that tendency to move from solid state to gaseous stage without passing through the liquid state? What do we call such material? So, and I want you to also give us few examples of material that can behave like that. What are the chemicals or the substance that have that tendency to behave like that? And not only that, like we said, there are some other ones that are also separation techniques that have not been captured. Some are what we do on daily basis at home that have not been captured. Can you just list 2 more or 3 more or 5 more other techniques that have not been captured in this discussion? And lastly, which method do you feel can be used to separate the following mixture? Which separation techniques can be used or is best used to separate the following mixture? 1. A mixture of petrol and water. Which of the method can best separate them? Petrol and water. Number 2, a mixture of ammonium chloride and common salts, sodium chloride, ammonium chloride and common salts. Which method can best be used to separate this? Number 3, which method can best be used to separate sand and coke? A mixture of sand and coke. Which method can best be used to separate them? Number 4, which method do you feel can be used to separate the component of ink? What method do you feel we can use to separate this, the component of ink? So please kindly help to write down all these opinions or your answer under the comment section. And I'll be so glad to go through everything and to answer and to comment your opinion and your suggestion. I will be so much happy and glad to see that. And we hope to continue from this in our subsequent class. So please go through it, and if you have friends that you know that need this production, please kindly subscribe to this channel, and also share with all your good friends so that they can also benefit from all we have learned today. Thank you.